Hokie dokie. In this problem, they ask which of the following equations describes a circle. So for a circle, we have our sort of general standard form of a circle, or equation of a circle, where we have x minus h squared plus y minus k squared equals r squared. The x squared and the y squared are the most important pieces. X squared and y squared will have the same coefficients. They will not ever have different coefficients. What do I mean by that? If we see an x squared and a 2y squared, that's going to lead to some sort of ellipse, not a circle. So we can eliminate any that are like that. Likewise, if we see not just the same coefficient, but you also need the same sign. So that also means pretty much same coefficient. The coefficient here is 1. Coefficient here is -1. If they have different coefficients, we eliminate them because that's not going to be a circle. I think option C there would maybe be like I think it's a hyperbola, maybe. I don't know. Anyway, so we narrow it down to B and D because they both have just regular x squares and y squares. Now, I would say the trick is, I'm pretty sure this works every time. The trick is this. What's the only difference between B and D? The coefficients on the end. -2 versus +4. I want to say you either just want to choose the lesser value every time for your answer, or the value that's negative, or both. I don't know. Like -2 is less than +4, and -2 is negative. I think you just want to pick the negative one, but definitely the less one, the lesser of the two, for your answer. That's kind of a shortcut. But now I'm going to briefly describe how the heck that represents a circle and why D does not represent a circle. And then I'll probably make a separate video doing 2 more examples of this one real quick. Okay, so for this one, what they, I think, intend for you to do is complete the square. So complete the square for the x and the y terms wherever necessary. So for B, I'm going to complete the square. There are no other x terms besides the x squared term, so we do not need to complete the square for the x terms, but we do need to complete the square for the y term. So we have y squared minus 2y. I'm going to leave a blank, and I'm going to go ahead and add this 2 to the right side to get 2 on the right side. Now, we're completing the square just with this y situation here. Completing the square requires us to take this b value, divide it by 2, and then square it. We get -1 squared, which is 1. So we add 1 on the left side, which means we have to add a 1 on the right side. Now, let's simplify a little bit what we're looking at here. Let's keep going. We have x squared plus, now let's rewrite all of this stuff as y plus or minus something squared. That something comes from this b value cut in half or divided by 2. So we just get y minus 1 squared. In other words, if we factored this or simplified this, rewrote this, we would get y minus 1 squared. Okay. And then on the right side, we still have the 3. And now we have an equation of a circle. Look at that. That's pretty cool. So this is an equation of a circle. And then let's talk about why this one would not have worked out. What's the only difference? The only difference is we would have started off with this equation. Bear with me here. All right, so we would have started off, instead of adding this 2 over to get a +2, we would have started right away by subtracting 4 to get a -4 on this side here. So then we still would have completed the square here by adding 1 on both sides, and then we still would have gotten x squared plus y minus 1 squared. But the issue is, what would we have been left with on the right side? -4 plus 1, which is -3. Why can this not represent a circle? Because, whoops, oh goodness gracious, the right side is negative. Why can the right side not be negative? Well, the right side is supposed to represent r squared, and if we got -3 as the radius squared, that doesn't make any sense, because anything squared would be positive, not negative. So that's impossible. So that's kind of the idea or the intuition behind why the last little constant there might be negative, or that might be a better choice than picking the positive option there. I think maybe like the constant could be positive, but it would have to be like very small so that whatever got added to it eventually would eventually be positive, something like that. I don't know. Hope that makes sense enough. Yeah, that's our little trick for completing the square, or for choosing which one describes a circle. But then that's the completing the square process to show why it does actually describe a circle and why D did not. All right. Talking in circles. All right, I'll see you in the next video where I just do 2 more of these examples very fast. All right.